Okay, so all of the methods in the XML tree are instance methods, i.e. you call them as follows. So you have t.method name and then the arguments, where t is an initialized variable of type XML tree. So it is an actual object. You can think of this as t. And that's how you call instance methods. You have an object, you have a method name, and then you have the arguments. Where t, in this case, is the object on which you are calling the method name. So .drive method would be called on a car. And all of the methods we're going to be talking about today must be called on an instance of an XML tree class. This is quite different from this right here, where you're simply invoking the class name to get a static method, because that class is not a real instance of an object. It's simply a representation of that class. So you're not creating a math instance to call the square root method. You're simply saying, from the math class, give me the square root method. And there's a very clear distinction between the two that you will have to understand. Okay. Definition, T is called the receiver of this call. For all instance methods, the corresponding distinguished formal parameter implicitly has the name this. This is something that a lot of people get tripped up on, but similar to the fact where we can define parameters for a static method, and we can also define parameters for instance methods as well, there's one additional secret parameter known as the distinguished formal parameter, which is known as this. So let's say we have a public int instance method, which I'm just going to call im, and it takes an int x. In addition to the integer x, which must be passed into the function in order for you to call this method on an object, you also have another parameter known as this, where this represents the object on which you have called the method. So you could say, let's just say we do print x. This is legal. And then you can also say print this. And this, in this case, simply refers to the object on which you're calling it. So if we have a class called test, we have an object called test. We could say test.im, and then pass in, say, an integer 4. Here's how you would call an instance method. In this case, since we do not know what the name of the object is going to be when we are writing the method, we simply refer to the name as this in the code. So let's say this was just a method where you were printing out whatever the object is, as well as whatever integer was passed in. You could call this on an object called test. You could call this on an object called foo. We don't know what the name of the object is going to be, so we use this instead. And it's known as the distinguished formal parameter. That good? Any questions so far? All right, 3 down, 62 to go. Okay, implementations of XMLTree. So there are 2 different classes that implement the XMLTree interface contract, and you may use either one. Like I said, XMLTree1 or XMLTree2. The choice is made when you initialize a variable of type XMLTree, where you must use the name of one of these implementation classes as the name of the constructor. I think I'm going to skip. Okay, there's a diagram. Okay, the behavior of an XML tree does not depend on which implementation you choose. This is a key benefit of design by contract. So when you're going to make an XML tree, you can either say, hey, I want an XML tree 1. Hey, I want an XML tree 2. No matter what choice you make, the behavior of that XML tree is going to be the same because we've defined what the behavior is in the interface. We set strict regulations on what an XML tree should be, how an XML tree should work, what methods an XML tree should have. So it doesn't matter if you're using XML tree 1 or XML tree 2 because they will both do the same thing. Their behavior is the same thing. How they get the job done might be a little bit different. So it's a key benefit. It's a cool benefit of design by contract. All right, here is the image that will be ingrained in your brain forever. It is an interface with 2 classes that implement it. So interface, remember, it's right to the left of it, so you can't miss it, describes an idea of what a class should be. So following that, an XML tree interface should be an idea of what an XML tree should be. It's a description containing constructors, which we'll talk about, and contracts for methods that should be included in the XMLTree classes. XMLTree1 and XMLTree2 are classes which actually implement those interfaces, so provide method bodies for all of those methods that are described in the interface. How that gets done is up to whoever's implementing XMLTree1 and XMLTree2. If we're writing an interface, we don't care. We are the ideas guy. We are Steve Jobs. We are simply saying, here's what an XML tree should look like. It's up to Wozniak or I don't know who the third Apple employee was, but whoever the other guy was to provide implementations. And that keyword implements tells you that class implements the interface above. There's another keyword extends, which I don't know if we get into today, but we might. But when we do, it's going to rock your world. It's awesome. Okay. The interface XML tree has method signatures and contracts for methods. Method signatures, who can tell me what a method signature is? Consists of two things. Right. So if I have public int im, int x, which part of this is the method signature?
The name and parameters. So that'd be im and int x.
Yes, exactly. So both the name of the method and the formal parameters make up the signature for the method. And that's what's included in the XML tree interface, as well as should have constructors as well. Okay, then the classes XMLTree1 and XMLTree2 have method bodies for all of those method signatures. It has to have method bodies for all of those method signatures. So you cannot, if you're implementing an interface, pick and choose which methods you want to implement. You must implement all of them, because otherwise Java will yell at you. That's like the big idea, is getting Java not to yell at you. The method bodies implement the method contracts in XML tree. Is that not the, oh, okay, yeah. So XML tree has contracts, classes implement those contracts, provide functionality. Then that third step, you can make objects of those classes to actually use the methods that you have written or somebody else has written. The method bodies in XMLTree2 implement the method contracts in XMLTree. So they both implement the method contracts in XMLTree, though maybe one does some things a little bit differently than the other. The actual way that you implement the interface is not important as long as you do it. As long as you fulfill the method contracts that are described in the interface, Java is A-okay with how you get it done. Okay, so we talked about the value of an XML tree variable is modeled, this idea of mathematical modeling, as a tree of nodes whose labels are explained in the previous set of slides. So we went over all about trees and how those trees work. An XML tree is just a instance of that tree. The model is described informally, though it could be formalized into mathematical notation, which we will not do here because we care for your attention spans. Okay, constructors. Constructors are how you tell, or how the client, whoever is instantiating an object, how to build a class. So there are two constructors for each implementation class. There are two constructors. There are two ways to make an XML tree. So when you're ready to actually make a implementation or an instance of an XML tree in your code, you're going to do it as follows. You're going to say which type you would like to make. So in this case, we want to make an XML tree. You're going to give it a name. So we can say, we're going to call it foo. And then we say foo is going to be a new XML tree. Now, here's where first distinction that you have to make is which implementation of XML tree do you want to use? So since we're making a object of type XML tree, we are allowed to make a instance of, I'm going to go back up to the photo, of either XMLTree1 or XMLTree2. So we begin with the interface on the left side, and then we describe which type of XML tree we want to make by either calling XMLTree1 or XMLTree2. And that's what will tell Java which implementation of the class to use. So you cannot just say XMLTree foo equals new XMLTree, because right now you're trying to instantiate an interface, and that interface has no implementations for the method bodies. It has no actual, it doesn't know how to run any of the methods because they're not implemented. It just has an idea of what the class should be. It doesn't have the actual implementations. So you need to define whether or not you want an XML3.1 or an XML3.2. Now, in these parentheses are what the constructor is used for. So when you're making an XML tree object, in terms of XML tree 1 or 2, there are 2 different ways that you can make it. We will only focus on one, which is taking in a string parameter, which is either the name of an XML file on your computer or the URL of an XML file for an XML source on the web. So we pass in a string, which is the name of an XML file, or a link to an XML tree on the web. You guys have actually used constructors almost every single time that you use a lab through the simple writer and simple reader class. So you say simple writer equals new simple writer 1L. So you're saying I would like a simple writer object. I would like it to be of type simple writer 1L. And then you pass in either a text file or the name of a text file, or you pass in nothing. Those are 2 different constructors for the simple writer. And it's telling Java how you should actually construct this simple writer. Should you construct it to output text to the console or read in text from the console? Or should you construct it to output text to a file or read in text from a file? Luckily for XMLTree, we're only worried about passing in the name of a file or a link to a web page, which has a well-formatted XML document. So we will always pass in strings. Does that make sense? Cool. Okay. A constructor has the keyword new before the constructor name is an expression, e.g. new XMLTree1. The value of this expression is determined by the contract for that constructor. So in this case, the contract says that the value is an XML tree corresponding to the XML document named by the string parameter. So this is an expression, remember expressions and statements, and this expression evaluates to an object of type XML3.2 in this case. And an object of XML3.2 with a parameter string which describes the XML tree. So either a .xml file or a web page which has an XML file. So we have this object, it's called foo. We can just say foo in there. And the big thing, this is a reference type, which we'll get into later. So this points towards some XML tree. Which I'll draw here. So this is the image that you should think about when this line of code is run. It's creating a new object pointing towards an XML tree. Okay, yeah.
Wait, what's the point of the string parameter?
That's what describes the, that's where you pass in either a .xml file or a web page which has XML for it. So that way it knows how to construct the tree. So it'll construct it for you. You don't have to do any of the parsing, which is good. But you have to tell it like where to go to find the XML tree. Okay. So tracing tables, welcome back. Before we have nothing. Then we run this code XMLTree T equals new XMLTree1 foo.xml. You have to make sure that there's actually a foo.xml file on your computer so that I can read in. Otherwise, Java will yell at you. So make sure that there is a well-formatted foo.xml file. It will take care of all of the parsing, but it will not create an XML tree for you if it's not a well-formatted XML tree. So think back to the one we had yesterday with like the dragon, and there was a color tag that was then closed before another tag. That is not a well-formatted XML tree. And if you try to pass that type of file to an XML tree constructor, it will not work. It will crash. Okay. Okay, see the slides on XML tree model for a description of the tree that arises from an XML document. So whatever foo.xml is, let's say it was the weather XML. T in this case would be an XML tree in Java that represents that entire thing of data for you, which is really nice. Okay. Now we're going to enter the method zone, where we just go over all of the methods that are described in the interface, implemented in the classes, and able to be used on objects of XML trees. All of these are instance methods, so you must call them on an instance of an XML tree. So you must call foo.label. Here's how you would call that method, foo.label. And similar to what we talked about, they are Java contracts. So they have ensures clause and requires clause, although I think the only requirement is that it must be of type XML tree. And this ensures that label equals the label of the root of this, not including the, what are those called? Less than or equal to signs for tags. So, for example, if we have T, which is a tree for a book XML example that we have, and we say string s equals t.label, let's say that the book tag looks like this. Who can tell me what the value of s will be after this method is called? Book. Right. It will just be the tag. So if the label is not a tag, harken back to the attendance question for the day. Let's say that it is a content tag, which looks like this. What will be the value of s after this code is run? Which is exactly Java for everyone, late objects. One thing we'll get into later, T remains unchanged. You'll notice that none of the methods that we talk about today will actually modify the tree. So there's no way to say, hey, foo.label equals, and then a string which says like Java for nobody, early objects. You cannot modify the tree. It is immutable, which is something that we'll talk about. Okay, let's roll through these. Is_tag returns a Boolean whether or not the label of the root of this is a tag. So it ensures that this tag is the label of the root of this is a tag. So again, we have a tree that is rooted at the book tag here, and then we call the is_tag method on this. So is this going to return true or false? Somebody raise your hand. True, because it's a tag. It has that little tag right there. So we'll return true. T remains unchanged. Now, label is not a tag. Please tell me that we can get this. Is Boolean B going to be true or false when it is called on this? False, because it's not a tag. Okay, good so far? And all of these are instance methods must be called on an instance of an XML tree. Okay, has attribute takes in a parameter, a name of an attribute, and returns whether the root tag of this has an attribute called name. And this is important because of the method we'll get to right after this. But as the example, if we have a book tag here, which has attributes print ISBN, web ISBN, and pub date, it's going to return a Boolean whether or not it has an attribute called pub date. So somebody raise your hand. Is this going to return true or false? True, because it has that attribute pub date. For example, or I guess in the contrary, does book have an attribute called foobar? No. So what will it return? False. Correct. Okay. Hopefully not anything groundbreaking here. So it's important to check if you have an attribute that's called something because of this next method, which is called attribute value. It takes in the name of an attribute and returns the value that's associated with the attribute of the root tag of this called name. Let's break this down. When you create a XML tree foo, what it does is it points to the root node of the XML tree. So all of the methods that you call on it, label, is_tag, has attribute, are referring to the root tag of the XML tree, not the entire tree. So it doesn't matter if you call has attribute and this one has an attribute called A, which is equal to B. It does not matter that somewhere in the tree there's an attribute called A, which has a value of B. It's only going to return it for the root of this. Remember, this refers to the XML tree on which we are calling it. So when we call foo.label, it's going to return the label of this. When we call has attribute, it's going to return has attribute for this. When we call is_tag, it's going to return whether or not this is a tag. not the entire tree. Okay, so if we've checked that it has an attribute, we can then get the attribute value of the current attribute by calling this attribute value method. It requires the label of root of this to be both a tag and to have an attribute called name. Why is it important that we make sure that when we're calling attribute value that it's a tag? Why does it have to be a tag?
Because tags are within the attribute.
Exactly. Content nodes do not have tags or do not have attributes. So we need to make sure that both, if we're calling this attribute value method, that it is being called on both a tag and a tag that has an attribute name called name. So if we have t and then we say, hey, string v equals t dot attribute value of pub date, what will this return? December 20th, 2011. And then another thing, notice every single one of every single type of both attribute and attribute value is of type string. So it wouldn't matter if this was, say, just the integer 7. It would still be returned to us as a string. Everything's a string. T remains unchanged. V is the string, December 20th, 2011. Okay, number of children returns the number of subtrees of the root of this. So if you remember, trees can have subtrees. Again, it requires that the label of root of this is a tag. Why? Exactly, because content nodes cannot have children. So in order to have children, we require that the label of the root of this is a tag. And it ensures that the number of the subtrees of the root of this is returned back to the user. This is all Javadoc contract. So again, it pops up again. So we're saying int n equals t dot number of children, where t is this XML tree rooted by the book tag, which it looks like has 3 branches branching off of it. So what will int n be? If it has,
Children.
yes. If t has 3 branches branching off of it, what will int n be equal to?
3.
3. So this tree t has 3 number of children. All right, any questions about any of the methods so far? Because I think this is where it gets hairy. Now we have a method which returns a child of the root of this, and you'll notice that it returns an XML tree. This is because, like we talked about when we were talking about trees, everything in a tree is recursive. So if I have a tree with 3 children, and maybe each of them has some children, this is a tree, but all of its children are also their own trees. So when we call .child, what's being returned to us is also a tree, which you could call label or is tag, or attribute value or has value. Any of the methods that we've talked about so far can be called on any of the children of an XML tree. It's recursive in nature. So in order to get those children, we have to actually dig through the family tree. So we pass it an integer k, which returns the kth subtree of this. It requires that the label of root of this is a tag, because remember, only tag nodes can have children, and 0 is less than or equal to k is less than the number of subtrees of the root of this. So if I try to call, let's say that this tree is foo. If I tried to call foo.child 3, it would return an error because there is no 4th child of foo. So we begin indexing at 0. Okay. So if we have our book example again, and we say that st is going to be equal to t.child1, this is going to return, again, an XML tree, only this time we are going to return st is going to be representative of the XML tree that is rooted at the title tag. So t is representative of the XML tree that is rooted at the book tag. The first child of that is the title tag. And that is now going to be stored in st. So now we have two trees, right? One is representative of the book tag or the tree rooted at the book tag. One is representative of the tree that's rooted at the title tag. And since you can call any method on an XML tree that is, okay, let me start again. Since a child of an XML tree is in and of itself also an XML tree, you can do funny things like if we have foo, let's say that foo dot child 0 dot child 1 dot child 2 dot child 0 dot label. We'll return the label of the first child of foo, the second child of that XML tree, the third child of that XML tree, the first child of that XML tree, that one's label. So you can dig into an XML tree if you would like. I don't recommend it because that's hideous, a hideous line of code. All code is beautiful, but that is not the best. I wouldn't recommend doing that, but you could do it if you wanted to. Don't, but you could. Okay. And then, yeah, here are the two representations of the tree. When we have a tree, which is a subtree, we do not, there's no way to go back. There's no way to look back up. We are treating that title tag as its own separate tree. We don't care that it is the child of a book tag. We are looking at it as its own separate tree. Okay, so yeah, continuing code from the previous example, this expression has the same value, type and value as st.child0. So st.child0 could be the same as t.child1.child0. So instead of looking at just the 0th child of the title of the tree rooted at the title tag, we could say that we want to look at the 0th child of the first child of the T tree. And what this expression has what type and what value. So if we were looking at both the first child of the second child of the T node, what does dot label return? What type? String. So it would be a string. String with the value Java for everyone late objects. Okay. Now we get into iterators, and iterators are complex. So we're going to pause here if anybody has any questions. Yeah. Yes. So content nodes will always be within two tags. Now you can have an example where I need to make some space. I'll erase this. Where a node can have both test can have both a label. Say this is flow. Have both a label child as well as a content child. So goodbye. So in this case, the XML tree would look like this, right? It would have both a test, and then it would have two children. It would have both this foo tag, which has, like you said, a content node contained within it. But then it also has just this content node, which is goodbye. So if text appears alone underneath of a tag, it is the child to that tag. What's next? Iterators. Okay, iterators are cool. An iterator lets you easily visit all the members of a collection of things without changing them while visiting them. So think of a collection of children, a collection of integers maybe, a collection of XML trees maybe. A collection of things you can iterate on is called an iterable. So things that you can iterate on are called iterables. And the collection classes of the Java library, which we won't talk about, and the OSU CSC components library have methods to give you an iterator for the corresponding collection, and thus are iterables. There's a lot of words. I don't even really know what some of them mean, but iterators are ways in which you can easily loop through and look at all of the values of a collection. how this manifests in terms of XML trees is it's an easy way to look at all of the children of an XML tree. So instead of a typical way, which you will learn is a way to look at all of the children of an XML tree, is to grab the number of children, loop through, and then call .child on each of the children. You can use an iterator to make things a little bit easier. Another way it manifests is through looking through the attribute values of a particular tag node, because you don't want to check every single string that exists. That would be painful. You can use an iterator to iterate over all of the attributes. For now, we will not further elaborate on what is meant by a collection, but you can probably guess what it is. It's a collection of things. So an example, suppose dictionary is some iterable. It doesn't matter which type of iterable. It's just an iterable of, say, strings. This code does something with each string in the collection. So how you read this is for each string word, we're calling word, in the dictionary, do something with word. And let's say dictionary had like 3 strings, like ba, and ta, for whatever reason. When we loop through, word is going to take the place of each of these strings. So let's say instead of do something with each word, it was just out.println word. First time, we print out then it will print out fa, and it will print out ka. Now, does something is a misnomer because it can do anything but change that word. So you cannot say add an extra H onto each of these words. You cannot change objects when you're iterating over them. It's like the big rule. It's like the golden. This is called a for each loop because you're saying for each string word in the dictionary, do something with that word. So, like I said, the way that this manifests in terms of XML trees is you can have an iterable, which iterates over strings. What types of strings? The attribute names. So this will return an iterable of the attribute names of the root of this. So if you call this on an XML tree, say foo, that'll return an iterator that allows you to easily loop over all of the attribute names of the root of this. And it's a lot easier when you just look at the code. So we're saying, hey, give me an iterator that's going to iterate over all of the attribute names of T. And then we have an iterator, and then here's the code for how you would do that. To iterate over the attributes, there's no need to declare an iterable. So you could declare it like this, but the easier way to do it, and the way that you should do it, is this here, is describing a for each loop that says, hey, for each string name that is in the attribute names of T, which is an XML tree, do something with the attribute name. So if we replaced do something with attribute name on this XML tree here with just out.println, it would print ISBN, it would print ISBN, web ISBN, and pub date out to you. Again, you cannot change it. They are immutable, which means non-changing. If you try to change a string within an iterator, Java will yell at you. Okay, back to another fun one. Display just displays the tree in a new window. Somebody wrote like a bunch of GUI code that lets you just explore the XML tree. So that's pretty cool. It's a void function, doesn't return anything, but it's still an instance function. So you have to call it on an XML tree object. You call like foo.display. And when you run this, Java code will stop and it will open up the display in a new window. I think you get practice with this in the lab. ToString returns an XML string representation of this. So if you would like to look at it in string representation, you can do that by calling ToString. One thing to note is that this is equivalent to the content of an XML file that, if identified in the constructor for an XML tree, would result in the XML tree this. So if you have, say, a web link, which has a well-formatted XML document, and then you load that into an XML tree and then print out the XML tree to a file. So call ToString and then print it out to a file. If you then loaded that file back into another XML tree, it would be functionally identical to the one that you got from the web. If you wanted to do that. I don't know why you wouldn't just use the web link, but you could do it. Okay, now we talk about immutable types. This is something that will come up again, so don't forget it, but a variable or an object can be either one of two things. It can be a mutable type, meaning that it can be changed, or an immutable type, which means that it cannot be changed. One thing to observe is that none of the methods that we've talked about today that you can call on an XML tree have been able to modify the XML tree in any way. So there's no way that if I have a XML tree foo, which let's just say represented this tree right here, there's no way that I can say, hey, replace that label test with another label called test2. I can't, because foo is immutable. It is non-changing. It is locked in place. As soon as you define that XML tree, you provided an XML file or a link to an XML file on the web, that XML tree is locked in place. No more changing. And that's what's known as immutable. This kind of type is called immutable. More details later, but if you would like a tease for how it works, integers, booleans, and characters are all mutable types, meaning after you make an integer x, you can call x plus equals 1, or x plus plus, or x minus minus. You can change that value after it's created. You can't with XML trees. Okay, there's the API if you would like to look at it. It has lots of fun things. But tomorrow you will get practice with XML trees and their methods in the lab. Are there any questions before we break for the day? 7 minutes early. Awesome. Okay, you guys can go. I will put the attendance code back up on the screen for those of you who showed up late.